All right, we're on review day 9. Today you're doing 11 through 16 and 18 through 24 on review sheet 3. We're going to do 4 of those, 12, 16, 19, and 23 together. So 11 and 12 are probably the longest problems on any of the review that we'll do. We've got to do our curve sketching. So with curve sketching, we first wanted to find the domain. The domain of this is all real numbers, but x cannot equal 2. Next, we can find our intercepts, x-intercept and y-intercept. So an x-intercept is when y is 0. So the fraction will equal 0 when the numerator is equal to 0. So if we take the numerator, it's not going to factor, so we'd have to do a quadratic formula. So we'll have negative b plus or minus the square root. B squared would give us 4. Minus 4 times a times c would give us minus 16 all over 2 times a. Notice we're going to get a negative under the radical, so there are no x-intercepts. Next up, y-intercept. A y-intercept always has an x value of 0. When you put 0 in for all the x's, you're going to get 4 over negative 2. So we'll have 0, negative 2. Our symmetry, if we put in a negative x everywhere, it doesn't come back exactly the same, and it's not just negated. So the symmetry, there's none. And our asymptotes, we will have a vertical asymptote at x equals 2. And then because our numerator degree is 1 more than our denominator degree, we're going to have a slant asymptote. So we've got to do our synthetic division. Out front, we put whatever makes the bottom 0, so we have 2. Drop down the first number, and then you multiply, and then you add. Multiply, and then add. Our answer is 1 degree less than we started with on top, so we'll have x to the first. So we have y equals x, no constants, and then the 4 is the remainder. And for our slant asymptote, we ignore the remainder, because when you go to infinity, the remainder is going to go to 0 anyway. All right, now we've just got to do our derivatives to find increase, decrease, max, min, and then second derivative to find concavity and inflection points. So we've got to do a quotient rule. Low, E high, minus high, D low, all over low, low. If we multiply the first part out there, we'll get a 2x squared. We'll end up with a minus 6x plus 4. We've got to distribute a negative, and then the 1 doesn't really do anything. So we have minus x squared plus 2x minus 4. All over our x minus 2 squared. When we combine like terms, we'll have a positive x squared, a minus 4x, and the 4's wipe out, all over x minus 2 squared. So we'll now do our number line. On the number line, you have to put anything that makes the derivative not exist. So in this case, 2 would make the derivative not exist. And anything that makes the derivative 0. Well, a fraction is 0 when the top is equal to 0. So I'm going to go ahead and pull out an x. So this is 0 when x equals 0 and when x equals 4. So something to the left like -1. Notice the denominator is always squared, so that's going to always be positive, so we just have to think about the numerator. So a -1 times a -5, negative times a negative, sorry, yeah, negative times negative is a positive. So now +1, 1 times a -3 is a negative. 3 would be a positive times a negative, which is a negative, and 5 would be a positive times a positive, which is a positive. So we are increasing from -infinity to 0, and again from 4 to infinity. We are decreasing from 0 to 2. We need to split this up, again from 2 to 4. Remember at 2 there's an asymptote, so even if it had switched signs, there wouldn't be any maxes or mins. We'll have a relative max at 0 and a relative min at 4. Remember, we already know that the y value for the 0 is -2 from the y-intercept. And for the min, to find the y value, we got to go back to the original. So we're going to fill in 4 here. So 4 squared is 16. 4 times -2 is -8. Plus 4 over 4 minus 2, which is 2. So this is 8 plus 4, which is 12. 12 divided by 2, which will give us 6. So we're going to have a min at 4 comma 6. So now we'll do our second derivative. We'll have low d high, make sure you're putting it in parentheses, 2x minus 4, minus high d low, we've got to do chain rule. So we'll have 2x minus 2 now to the first, times the derivative of the inside, which is just 1, all over low low, which will now have it to the fourth. Usually in your second derivative, you get something to wipe out. It's got to match in the bottom, as well as in the first and the second term. They all have an x minus 2. So we'll take one x minus 2 away from each of them. It's got to match in all spots. Without recognizing that, it makes the problem really, really hard. So you want to be on the lookout for that. We've got to FOIL out the first part here. So we'll get 2x squared. We'll get a minus 8x and a plus 8. Over here, the 1 times the 2 gives us 2. 2 times the negative here is -2. So we'll distribute a -2 through. And we get -2x squared plus 8x all over x minus 2 to the third. Quite nicely, the x squareds cancel out, the x's cancel out, so we just have 8 on top. On our number line, we have to put whatever makes it undefined and where it's 0. Undefined still at 2. Its fraction is 0 when the numerator is 0. Well, the top is always 8, so it never will be 0. So we just have the 2. If we put something like 0 in, we'll get a positive over a negative. So that's a negative. If we put something like 5 in, a positive over a positive. So we are concave up from 2 to infinity. Concave down from -infinity to 2. And although it switches concavity at 2, remember 2 was an asymptote, so there is no inflection point at all. If it was not an asymptote there, we would have an inflection point because it switched concavity. All right, we're going to go to graph this. First, plot any points you know and any asymptotes you know. We know we have an asymptote at x equals 2. We also have a slant asymptote of y equals x, so start at 0 and go with a slope of 1. And our other points we had the y-intercept, which was also a min at 0, -2, or a max at 0, -2, and a min at 4, 6. So we'll extend those asymptotes a little further. All right, so now we sketch in with concavity and we check with increase, decrease. So we should be concave down all the way up till 2 and concave up after that. So we are concave down, make sure you hit the max and go along your asymptotes. Concave up, make sure you hit your min and go along the asymptotes. We were supposed to increase up until x equals 0, which we do, decrease, and then decrease again, and then finish with an increase. So that does check out. All right, next we're going to look at 16. So we're going to do a Riemann sum with the midpoint rule, and n is equal to 4. So we first start out and find our width. So we'll have 6 minus 2 over our number of rectangles. That's 4 divided by 4, which is 1. So our intervals are going from 2 to 3, 3 to 4, 4 to 5, and from 5 to 6. So our midpoints of those are 2.5, 3.5, 4.5, and 5.5. So we've got M4, because it's midpoint with 4 intervals. We'd always put our width out front, because it's a base times the height for the rectangle, really. The base will always be 1, and the height is just the y value with our midpoint subbed in. So we have 8 over 2.5 squared plus 1 plus 8 over 3.5 squared plus 1. And do that for each of the 4. Okay, and this isn't an exact value, so you could just leave it like that if you want. And without a calculator, it might be tricky to do the 2.5 squared, so that's probably your best bet. So that value represents the approximate area underneath our curve. We're going to go to 19 next. So capital F of x is equal to this integral. The main thing to note is we're going from a number to an algebraic expression. When you go to take the derivative of this, this is our first fundamental theorem of calculus. All you do is you put the algebraic expression on top in for the t. So tan fourth x we now have, and then you multiply afterwards by the derivative of what you subbed in. So here we just got times 1. If we had been subbing in x squared, we would have had tan to the fourth x squared and then times 2x. But our derivative of x just happened to be 1 here. And then that's it. And we'll finish off with 23, which is one of our summation formula ones. Your summation formulas are on the front page of review sheet 3. So we want to rewrite this as 3 summation k equals 1 to 14 of k squared minus the summation of k equals 1 to 14 of 10. So our n in this case is 14. The squared formula is n times n plus 1 times 2n plus 1 all over 6. So this is 3 times 14 times n plus 1, which would be 15, times 2n plus 1. So if we double it and add 1, we get 29 all over 6, minus our constant formula is the constant times n. So we would have 10 times 14. And then this is an equivalent value. You could leave it like this if you want, or you could neaten it up. It's your choice. All right, so again, you're doing 11 through 16 and 18 through 24, the rest of them that are there on review sheet 3.